The different experiences and interacting with the environment that are happening in each year actually shapes the right brain into the right brain. It forms in the first 6 years these clear differentiation between what they're good at and what they do. As the brain matures, the two hemispheres become more and more and more different, but at the same time, they need to become more and more and more synchronized.
Our next guest, Dr. Melillo, has over 30 years of clinical experience, has written 8+ books, including the bestseller Disconnected Kids, and is best known as the founder of the Brain Balance Achievement Centers, a program designed to help children, and now I learned adults, with ADHD, autism, and learning disabilities without medication.
There was a study on nuns where the average age was like 90, and none of these nuns none of them had ever had a history of Alzheimer's or any sort of dementia, right? Which we know is like 50% of the normal population. So they studied them to figure out why. And it turns out that these nuns were...
Hi, my name is Chris Burris. I'm a longevity expert and the chief scientist at a lab focused on a longevity molecule. My primary focus is to help people live longer and better lives with science. Make sure to subscribe and share so you and your friends can live longer and better, so you and your friends can live beyond the norms.
Hi, and welcome to the next episode of the Live Beyond the Norms Health and Longevity podcast. Our next guest, Dr. Robert Melillo, is a leading expert in childhood neurological disorders, and really we could just say neurological disorders. Dr. Melillo has over 30 years of clinical experience, has written 8+ books, including the bestseller Disconnected Kids, and is best known as the founder of the Brain Balance Achievement Centers, a program designed to help children, and now I learned adults, with ADHD, autism, and learning disabilities without medication. Dr. Melillo's work centers on functional disconnection syndrome, his theory that many developmental disorders stem from imbalances between the brain's hemispheres. Through his program, he has helped thousands of families see life-changing improvements in their children's cognitive and behavioral development. Whether you're a parent, educator, or a neuroscience enthusiast, today's conversation will provide fascinating insights into the brain's ability to heal and adapt. Dr. Melillo, thank you for joining us today.
I'm excited to be here. Thank you very much for having me.
Excellent. So before we jump into your area of expertise, I'd like to go back, like much further back. What was it like growing up as little Robert, right? Before it was Dr. Robert. Where did you grow up? What were your parents like? If there was something, some event or some person that you could pinpoint as the reason you would ultimately become a neuroscientist, the author of 8+ books, the founder of Brain Balance, which I think has 90 locations, what or who would that event be?
Well, it was right after the dinosaurs were extinct, but no. That was a big event. Yeah, it's interesting because looking back, one of my favorite quotes is that when you're going through life, all these things that are happening to you seem random and unconnected. And then when you get to a certain point, you can look back and you realize that nothing was random, that it all was actually connected. So, from a very early age, I was very involved in sports. I was very much, my brother and I we lived for sports when I was a kid, got into exercise and health at a young age. But I also like kind of science a lot. My brother and I were really big fans of comic books, and, we used to talk about like the physics that they would talk about in the, comic books were really way ahead of their time in the 70s and 80s, and, talking about like things that nobody was talking about, like quantum physics and things like that. And so we were into evolution. We were into, ancient astronauts. We were into like all different types of cool things as kids, and we would talk about it. And so a lot of my curiosity around science and around that really, and health was really kind of fostered then. But I remember even my first paper that I ever did in 6th grade was on schizophrenia. I just was fascinated by it. And I remember, there was always a quote that was interesting when I was a kid. I love to watch biographical movies or books about athletes or famous people or really successful people. And they always seem to end tragically, like end with suicide or drug addiction or alcohol. And that whole saying of there's a thin line between genius and insanity. For me, I remember as a kid being like, why would that be? Why wouldn't somebody be a genius and be happy? Why do they have to, die of drugs or something? And I never really understood it, but I wanted to understand it. It was like this paradox that I wanted to figure out. And I remember that also, I put this in the beginning of my book, Disconnected Kids. When I was 16, I read the book Catcher in the Rye. And I remember I used to really like reading books, and I loved figuring out what the author was trying to say and what was the hidden meaning of the book and all of that. It's a very right brain thing to be able to do, right? And I remember Catcher in the Rye, I was reading it, and I was like, I don't see any meaning in this book. Like, everybody talks about what a great book this is, and I didn't really see any meaning. It just seemed like this kid was this miserable kid that just bitched and moaned all the time. And then it got to a point, this one part where, the guy, Holden Caulfield, was talking to his sister, and she was asking him about, what do you want to do? What do you want to do when you grow up? What do you want to be? And he said, I really don't know. He said, I'm not sure, but he goes, I think about that I'm in this big field of rye, and I'm the only one around that's big. And otherwise, there's all these children, these small children running around. And he said, and they're running through the rye, and they can't see where they're going. And there's a cliff that they're running towards, and they don't know they're running towards a cliff. And he said that I want to be there and just be able to catch them before they fall. I want to be able to stop them from falling off the cliff. And he said, I just, I don't know why, but that's the only thing I can think I want to do. And I thought about that. I remember it hit me when I read that part. All of a sudden, the whole book came together for me, and I was like, boom! It hit me like a lightning strike. And and then I put it away and thought about it, and I didn't realize till years later that, he said he just wanted to be the catcher in the rye. He wanted to save children. And I realized that kind of inspired me at that point and kind of led to what I do. It's like, there's this developmental trajectory, and kids are kind of, if they're not developing properly, they're kind of going over this cliff. And my job is to kind of bring them back on the cliff. No matter what stage of their development they are, we can bring them back, and we can get them back on track, and we can get development back on track. And that's kind of, I guess, my origin story.
I love it. So one thing, usually in these interviews, I get more homework, so I have to go back and reread Catcher in the Rye. So thank you. more homework. I'm sure I'm going to enjoy it. You talked about comic books having a lot more to them. We actually had this, my dad was in the Air Force. We moved every 2 years, just kind of interesting story. We had some good family friends, and we would play Trivial Pursuit, and their youngest son would slaughter everyone. Now, he was obviously a really bright kid to begin with, but you were like, where do you get this information? And he was like, comic books. Like, because they're accurate, the physics is accurate, the history is accurate. Anyway, so like, absolutely believe that. Super young age, you're choosing the topic of schizophrenia, right? And then what a great origin story with Catcher on the Rye. Well, so you've got this, and maybe you didn't realize it in that book. Later, you realized, as you were kind of pursuing neurological disorders with kids, like walk us through that, right? How did you get into neuroscience and working with kids? And did you actually have any challenges as a kid that might have kind of motivated or around you other than this Catcher on the Rye kind of experience?
Yeah. So, I was, as I said, I was very athletic as a kid and played college football, and I had a number of injuries, and I was very interested. Sports medicine as a science wasn't really even developing then, but it was just starting to emerge. And so for me, I really believed more in a natural approach to healthcare and medicine, and a chiropractor had been the one that had helped me the most when I was injured or sick. And it just was a natural gravitation. I was always very interested in anatomy and physiology and science and biology. And so I had a choice. Am I going to go to medical school or chiropractic school? And it just made more sense to me to go that way. So I went there. And when I was there, I didn't even realize how founded in neurology and neuroscience chiropractic was from the very beginning. That's really the whole basis of it. And I fell in love with neurology then. And I always wanted to try to figure out to combine like some neurology and kind of like sports medicine approach to the brain and the nervous system. And then when I graduated, I went into a neurology diplomate specialty for another 3 or 4 years and got board certified in that. And then I went into another one in rehab. And then, I was very active in my practice at the time, and we were doing really high level, sophisticated neuro rehab. And I was already started teaching clinical neurology and doing research, but then I came home one day and there was a woman sitting at my kitchen table with my wife and she was crying. And my wife introduced me and said, this is Denise. Her son has ADHD and maybe autism. And, she'd been trying everything. She started this big organization. My wife met her at a fundraiser the night before. And she was very upset because she's tried everything and nothing's helped. And, there was a lot of violence last night. And so I told her, you know a lot about a lot of things and you kind of think outside the box and, you know a lot about the brain and maybe you could help her. And so I said to my wife, I grabbed her aside and I said, I see what you're doing. This is very nice. I'm coming in at 9:00. I have 3 little kids. I haven't seen them myself. I'm already lecturing on weekends. You're mad at me most of the time. And, you really want me to do this? And she said, yes. And I said, I don't really know what ADHD is. And she said, well, I feel like this is something you're supposed to do. I don't know why. I just think that you're meant to do this. And I said, all right, I can't, all right, I'll do what I can. A couple of days later, I went to my oldest son, who was about 5 or 6 years old. It was his first grade, and it was my first parent-teacher meeting. And I walk in there, and the teacher says, I don't know how to tell you this, but I think your son might have ADHD or something like that. He's very hyperactive. He's very bright, very talented kid. He's a great artist, but he never sits down with the other kids or anything. And so now I'm thinking, well, first I'm embarrassed because I think here I'm an expert supposed to know about the brain. I don't even know what this is. I don't even see it in my own child, right? So now I feel like, I'm negligent that way. Then I feel like most parents feel when they hear something like that. I feel like I'm to blame sometime because I'm working too much or I'm not around enough for my son or whatever. But then I look at my wife and I hear her saying, you're supposed to do something with this. And I kind of take that as a message and I think, okay, this is my challenge. I need to figure this out. And that was the first question that popped into my head. What is it? What is actually happening in the brain? I was already thinking in a neuroscience standpoint, like what's the neuroanatomy of it? What is actually happening? So I went out to a bunch of colleagues that I hoped would know the answer, pediatric neurologists, pediatricians, psychologists, neuropsychologists, psychiatrists, all colleagues of mine, friends I knew. And I said to them, what is ADHD? What's happening in the brain? And they all looked at me and said, I don't know. I don't know if anybody knows. I mean, something maybe with dopamine or the frontal lobe, but I don't know. They said, why? I said, well, someone told me my son might have it and I want to see if I can help him. And they said, well, you can't help him. I was like, what do you mean? They were like, yeah, you can give him medication or something, but you can't change it. And I was like, you just told me you didn't know what it was. How do you know you can't change it? And they were like, oh, I don't know. Well, that's what everybody says. And I was like, okay, so I need to jump in and do this for myself because if there's a way of helping my son, I'm going to find it, right? Because now my father jumps in like me, like this is my son. And then it was this other woman's son. And so then I kind of dove into it and then all this information just started coming to me that really kind of led me down the road. And after about 10 years, I compiled all this research and I wrote a pretty massive textbook called Neurobehavioral Disorders of Childhood and Evolutionary Perspective that was published by the #1 publisher in the world in neuropsychology at the time. At that point, I knew the answer. I knew what the problem was. And it wasn't just about ADHD. It was about the whole range of neurobehavioral issues. And it wasn't just about kids. It was about brain development throughout the lifetime. And so then it was about, okay, what do I do to change it? And during that way, I'd been experimenting with different things. And I had helped my own son to change it. and then other people. And then, my other two kids also had issues. But, they were also incredibly talented and gifted. And that's what was confusing. They were so good in certain things, but struggled in others. And that's right from the beginning, to me, it seemed like some sort of an imbalance. And ultimately, that's what I was able to discover, that there was this developmental imbalance. And that's what our research has proven. And that can be changed. That can be changed at any point in someone's life.
So I certainly have a lot of empathy, right? So I have 14-year-old twins. They were kind of diagnosed with ADHD pretty early on. It's interesting how it manifests. It's interesting, part of it was interesting. So with young girls, the audience member, you would know this, but the audience might not. It's hard. It is often delayed to diagnose because they tend to just kind of sit there and count ceiling tiles because they're distracted. Whereas the boy, literally my son, was on the principal's desk at one, like my first meeting, the principal started off with, "Your son was standing on my desk," which I want to laugh like you did, because that's a reasonable response, but I cannot laugh because my son was just standing on his desk.
Right.
And so it's been an interesting journey. I want to go back. Your first book, I hadn't really keyed in on the title. You had evolutionary perspective. I don't want to take too much time because I think there's a lot of meat, but how did you fold into that book, like evolutionary perspectives? Is there an evolutionary advantage to having some of these things that you kind of theorized or put further evidence for?
Yeah. So again, going back to comic books, I always loved origin stories, even of the villains, maybe especially of the villains. Where did it all start? So when I first started trying to figure this out, I spent years compiling papers, and literally it was in this room behind me. I literally had on the floor stacks of papers that I've read, that I've literally go to a medical school and go to the library and literally sit there and read through the journals and then stand by a copy machine and copy these things off, right? This was before the days of the internet and being able to do that. And so I literally read all these papers and all these books, and I was literally looking at it going, okay, in this group is the answer, but I couldn't quite see where it was. And so I wanted to go back to the beginning, and it was like, okay, well, we're talking about behavioral issues and learning disabilities. What is learning in the brain? What is behavior? Where does behavior come from? And then a more basic question, which is, well, where do brains come from? What was the first brain that evolved? Why did it evolve? And so that really came down to, there were some really good researchers at the time that had written on this, a guy named Rodolfo Linus in particular. And, the idea was that the reason why we have brains is because a living thing moved. When a living thing moves, under their own power, it requires a brain to be able to guide that movement and predict what's going to happen. Living things that don't move don't have brains. So movement was the initiation of brains on the planet, and movement is the initiation of brain development in children. And right from the beginning, because I had started off really being about movement and looking at motor activity, and, and I was into rehab. So that resonated with me, that, okay, so movement and what alters movement and changes brain development, which ultimately changes growth. And the way that we look at there's a famous quote that says, ontogeny recapitulates phylogeny, which means the developmental stages we go through from an embryo through birth through the first year, we're really going through all millions of years of evolution. And our brain is just built on top of all the other brains that ever existed. So, from a standpoint, it really mattered because, these were brain developmental issues. And brain development was a mirror of evolution. So understanding the evolutionary development of the human brain and what made the human brain unique, which was really bipedalism, right? Being bipedal. That's what makes our brain unique, and the size of it and all of that. So, when looking at what can we do about it and how can we identify this early, looking at changes in early movement. And we know that one of the most common symptoms that we saw in any sort of learning disability and neurobehavioral was what's called DCD, discoordination disorder, or problems with coordination, whether fine motor, gross motor, alteration of low tone. So right from the beginning, that's where that started for me.
Interesting. So I think back to when my son was younger on a playground. Well, they'll have these little bridges with slats, and I remember he would you have this understanding that cows stay inside of their pen, right? Because there's these slats that cars can drive over, but cows won't approach them because of depth perception. So he had some sort of depth perception challenge. So yeah, all of this makes sense. Let's get to your theory, right? So and I don't think it's your theory, but I think you're probably the biggest proponent of the theory at this point. And correct me if I'm wrong there. Called Functional Disconnection Syndrome. Explain what this is, how it kind of contributes to conditions like ADHD, autism, and dyslexia.
Yeah. So, in the early 90s, Bill Clinton declared the 90s the decade of the brain, and all this brain research came out, and all these new ways of imaging the brain in real time started to come out, which we didn't have those tools before. So, people would speculate as to what was happening. And, really there were lesion studies where you'd look at an injury in an area of the brain or a stroke and try to extrapolate out what was happening. But now we could look at the brain without an injury or without cutting it open and really measure it functionally. Before we could just kind of look at it structurally, but now we could actually look at function. And with that came the understanding and the concept that most problems that were brain related in mental health or learning or whatever were a problem with functional connectivity. That where there wasn't damage. So there was something called a disconnection syndrome, where if you literally, took a scalpel and cut white matter, right? Where if you actually cut it, so you physically disconnected the wires that connect different networks. That's called a disconnection syndrome. And there's characteristic things that you see. But what we were seeing is what looked like a disconnection syndrome, but there was no cut, there was no damage, there was no injury, and it became known as a functional disconnection syndrome. And so it wasn't a lesion or anything wrong in the brain. There wasn't a chemical problem in the brain. It was a breakdown in the ability of the brain to communicate. And it really comes down to a lot of timing and coordination and synchronization and things of that nature. So that was really becoming known as this is the problem. And there was more and more people coming out starting to say, well, we look at all of these things like ADHD and autism and OCD and Tourette's and tics and learning disabilities. And there's a lot of comorbidity, which means that, no kid just has one diagnosis. They have multiple ones. And kids with autism kind of have everything. So there was more people starting to say, well, maybe there's really one underlying problem here that is really the core root problem that we don't really understand fully yet, that is showing up in different ways or different flavors that may have different symptoms, but there's a tremendous amount of overlap there. And we can't see it on a brain MRI. We can't really see it, but we can kind of measure it a little bit. But we can see it, right? And that was kind of the beginning of the concept of functional disconnection. And one of my research partners was one of the people early on talking about that. But as far as the idea of how this relates to the development of the hemispheres, and then how it comes about during development, like what's the cause of it, that was kind of my contribution to this, as far as how that came about and how that was related to developmental milestones and things of that nature. And also, how do you change it? Nobody had ever said, all right, what do you do about this? Other than just trying to manage symptoms, how do you change this core root problem in the brain? And again, what we also noted was, like in things like autism, whatever, there was also a lot of immune issues, and there was digestive problems and, autoimmunity and inflammation and hormonal issues and detox issues. So the understanding that the brain regulates everything. And so when there is problems in the brain and the networks, it doesn't just produce mental problems or behavioral or learning. It can produce every aspect. It can cause imbalances in every system in the body. And we see that especially in something like autism.
It's interesting that first, it makes perfect sense. The brain controls everything, right? So if you're having some sort of challenge in the brain, it can have a negative impact physiologically anywhere. Interesting, right? One of the, I think, kind of the neuroscience is known for a long time that splitting the lobes can have a positive impact in places. Like, so one of them is, I believe, epilepsy, where, one hemisphere starts firing. How do we if we can just prevent it from getting to the other hemisphere, that helps. There's and I know these incredibly fascinating results when you split the hemispheres and you end up with like two people in the same brain. Like those studies, if the audience doesn't know what I'm talking about, you literally will give two answers to the same question if your hemispheres aren't communicating, because there are two people wrestling to provide the answer. It's amazing. Go look that up. You kind of said, okay, I buy into this hemisphere challenge. I buy into this evolutionary aspect. So you start putting, like, I'm just thinking, I would start putting together, well, what are the steps that maybe got missed? Am I thinking about that right? Like, what steps got missed as this particular human, whether they're a child or an adult now, it was progressing, and then you start trying to hit those markers. Is that kind of your first approach or the current approach?
Yeah, one of the first things when I first started doing the research, I came across a concept in the research called an unevenness of skills. There were a lot of researchers saying there's these unevenness of skills in these kids where they're not bad at everything. In fact, they're really good at certain things, maybe even gifted or genius level, while they struggle with other things. So right off the bat, as a rehab mentality, it's like, that sounds like an imbalance of some sort. And I started saying, okay, with ADHD, let's say, what are they really good at? And what are they really bad at? Like, what is it? So I started really looking at it and going through it. And at that point, I was already teaching. We were already teaching some aspects of the hemispheres and how they work and how they work together. Because again, that research was emerging more and more and more. And as you said, it all started with that split brain research in the 60s in California with three guys named Joseph Bogan, Philip Vogel, and Roger Sperry, who did that for epileptic seizures. And like you said, there's been tremendous amounts of research that has come out since then. It's fascinating stuff. So this was like the culmination of that. So I started looking, and I realized that in ADHD, that everything that they were really good at was a left hemisphere skill, and everything that they really struggled with was a right hemisphere skill. And I looked at it and I was like, could it be that clear cut? Like, it can't be, right? That'd be too easy, right? So I started looking more and more at like autism, and it fit even more. I started looking at dyslexia, and it was the exact opposite, but the same thing. And I started looking at that saying, wow, this is kind of crazy. And then how does this impact the immune system? And the same thing. How does it impact our hormones? How does it impact the sympathetic and parasympathetic nervous system? And it all fell into place like that. And then I started saying, well, how does this start? How do we get a right brain and a left brain? Like, how does that happen? You think, well, there must be genes that make our right brain and our left brain, but really there's not. It's really more environmental interaction. And the only genes that really regulate that is that when our brain is developing in the first 3 years, primarily the right brain takes the lead. So in the womb and for the first 3 years, the right brain is more dominant than the left. And then for the next 3 years, the left brain comes in. And the different experiences and interacting with the environment that are happening in each year actually shapes the right brain into the right brain. It forms in the first 6 years these clear differentiation between what they're good at and what they do. And then as we use them more, it gets more and more and more. And that's as the brain matures, the two hemispheres become more and more and more different. But at the same time, they need to become more and more and more synchronized. Our brain waves get faster and they become more coordinated. And this is called vertical integration. It starts from the bottom up and then comes down to regulate, and then horizontal integration. So when I saw that, I was like, oh, okay, so this is where the problem can begin. If something affects the womb or the first 3 years, it has more of an impact on the left brain and on the right brain, and the left brain might get too much in the lead or come online too early. Or if it's the other way around, if the right brain hangs on too long, it can delay the left. And so this was the mechanism of where this imbalance could start. And now I had the answer of where does it start? How does it start? And that was kind of a real epiphany for me.
And then I would imagine we'll get to it. Like then the focus is like, how do I kind of balance these things?
Exactly.
Before we go there, are animals with brains, do they all kind of operate the same? Like where the right brain develops, are they do they have this left and right hemisphere? And I've never even really thought about, does a dog have a creative brain and a logical brain?
Yeah. We actually wrote a paper that came out in a journal called Symmetry in 2023, where we went through, going back. It's really well documented in the fossil literature that going back even 500 million years ago, that the earliest brains were asymmetric from the beginning.
Oh.
And so they looked at trilobites, and there was predators that were around at that point that would feed on these trilobites, and they only attacked from the right side, which means they were right-handed or right part, which means there was already an asymmetry in their brain going back then. So from the beginning of time, the norm has been brain asymmetry. And we know that there's two basic behavioral platforms. Again, as soon as you move, you have a choice. Do I go toward or away? Do I approach or avoid? And right from the beginning, that's the basic platform of the two hemispheres of the brain. The right brain guides avoidance, withdrawal behavior, and the right brain is approach behavior. So we see that dichotomy right from the beginning, and it really makes a lot of sense. And it makes sense to have, different parts of the brain that do different things. People tend to think, well, there's this thing called the amygdala, and they're on both sides of the brain, and they do the same thing because we see them both light up. That's not the way it works. One will be on, or one will be activating, the other will be inhibiting. So we see this dichotomy early on, and it's really important. So all animals do have a certain level of asymmetry. As the animal becomes smarter and smarter and smarter, there is more and more and more asymmetry. As you go up the evolutionary scale until you get to primates, which have the most, but humans have the most asymmetric brain, and we have the biggest brain per body size of all primates, but we're also the only bipedal primates. And that's where the real difference in our brain, one of the main things is human brains, when we're born, we have the most immature brain of any brain on the planet because we have the biggest brain per body size, but because we're bipedal, we have the smallest birth canal. So we have really big heads with really small birth canals. So we have to restrict our head growth in the womb so that it's only about 20% of its adult size when we're born, with every other animal is like 80 or 90% when they're born, right? Or certainly much more than 20%. And that's where our advantage and our vulnerability in brain development come into play.
Very intriguing. Can you assess, do you think we can assess like dolphins? I know they have right and left brains because I know half of it goes to sleep at times because they have to be able to be awake to go up and get some oxygen.
Right.
Can we assess just how intelligent an animal, and does that exactly correlate? Like how separated the two hemispheres are?
Yes, we do know that, again, as the brain becomes more asymmetric, the animal is smarter. And we do know that at the highest level, probably the highest level of intellect, is self-awareness, right? To become self-aware. So humans, like Homo sapiens sapiens, it means the wise man that knows he's wise. And there's only 5 species of animals that we know that actually have mirror recognition, meaning they look at a mirror and they know it's them. And it's dolphins and it's elephants, humans, chimpanzees, and species of bird. I think maybe like a crow or something. And they're the only animals that we know of that we've documented that actually have that mirror recognition. Children, human children, achieve that around 18 months to 2 years, where they suddenly recognize themselves in a mirror. From one day to the next, it can change. What's very interesting is many kids on the autism spectrum and even ADHD, if they're delayed, they don't get mirror recognition until much later, or maybe not at all. And they don't recognize themselves in a picture, and they don't yawn when other people yawn.
Oh, interesting. So the mirror neurons are not as attuned.
Right, because the right brain is what does that. The right hemisphere is responsible, and they have a severe delay in the right hemisphere, and that is really the root cause there.
Interesting.
Hey, super quick break from the podcast. Hopefully you're loving it. This is a way you can support the podcast and take advantage of a great offer. We're offering 50% off of one of our MCT bottles. MCT is an amazing oil. Add the ESS60 molecule to it. It's even more amazing. All you got to do is leave a review on iTunes, send us a notification that you've left that review. We'll get you a coupon code that'll get you 50% off of our MCT oil and free shipping. Back to the podcast.
What are some of the like maybe early signs or kind of lighter signs of a brain imbalance that you might see in a child, and then obviously all the way up to kind of a full-on severe case of autism would be a key a great indicator. Like what are early things that you might notice?
Sure. Remember I said that human brains or brains formed on this earth because of movement, and that brain development is all about movement, right? So the best way to look is to really look at early movement and even pre-birth movements, right? So this is one of my main areas of research that I kind of know more than anybody in the world right now, something called primitive reflexes. We're born with certain reflexes. Because our brain is so immature at birth, we don't really have a motor cortex. And our brain has to not grow too soon. But then when it's outside the womb, it needs to grow really fast. And so the genes that regulate brain growth, which makes up 85% of our genes, really have to be very sensitive to the environment. They're the most sensitive genes, which make them the most vulnerable genes for something not good to happen to them. So they need to be able to know when they're inside versus outside and when they can grow and when they don't grow. So when we're outside, they get bombarded by sensory stimulus, which turns them on and causes the brain to grow. But what drives that is movement. We have to move to engage our senses, to interact with the world and calibrate our brain. Our brain is born with all this kind of software already preloaded, what we call stereotypical behaviors that really go back in evolution, like the idea of even our facial expressions and most of our actions and movements are, something that we all do. And so what we see is that, but to really get that software to come out, we need to use it, we need to interact, and we need to calibrate it so we come out with the right program at the right time. And that is an advantage. If we don't, that's a disadvantage. So movement is what starts it. And even before birth, there's these things called primitive reflexes that come from the lower brainstem because we don't really have much of a brain yet and a motor cortex. We don't have any control over our own movement when we're born, but we need to move. So we're born with these reflexes that give us this basic automated movements until our brain grows and it takes over, right? So even before birth, babies automatically around, the third trimester get into the right position, turn upside down and backwards, and do that without the cord getting wrapped around their neck. How do they do that? Well, because these reflexes are there and they come online at a certain point and they get the baby to do these movements. And so if a baby's in a breech position, if they're not in the right position, if they're sunny side up, if they get the cord wrapped around the neck, something about this movement is not happening the way it should right from the bat. And then these movements should be used to get the baby and help them get themselves out of the birth canal. If they get hung up on the way out, if we need to use forceps or something like that, again, something's not happening. So if there's already this delay in development that these movements aren't coming on when they're supposed to, when they first come out of the womb. Now, the first milestone that we see a lot is, a baby should be, if the mom chooses to breastfeed, a baby should be able to latch on right away without any problem. Most of the kids we work with, 85%, they don't latch on initially effectively. Some, are delayed. Others are not at all. And so right off the bat, again, that isn't working. And then we look at when do they roll over, and do they roll over to both sides in the right way? Do they crawl on their belly in the right way for the right length of time? Do they get up and rock and then crawl on all fours, perfectly balanced and symmetrical, and sit up and pull up and stand up? And right around 12 months, every kid should be able to take a few steps, say a few words, and be able to have good eye contact and point. And then at that point, these reflexes go away, right? So it leads us through these milestones. And as we go through this milestone and get more complex movement and interact with the world and the brain grows, it starts to inhibit these reflexes and then allows more complex movement and different reflexes. But by the time we get to one and we stand up and walk and talk and point, they should be gone. But if they're not coming on time, we see babies that don't roll over, or they hate being on their belly, or they don't do the commando crawl, or they go right to the crawling, or they hop, or they do the worm, or they scoot on their butt. They have some deviation of normal, and then they may not crawl at all, or they may walk at 18 months or 2 years or 24 months, really, really late. They may walk, but they're not speaking. They may walk and say a few words, but not point or not have any eye contact. And what we see and what I've been able to prove is that what's happening is that if these reflexes aren't coming on, they don't go away when they're supposed to. And if they don't go away, they hold the brain back. And now what happens is they're holding it back, and the right brain is at its peak of development, so it gets impacted more. And kids with autism are genetically gifted. Every single one of them is a genius with their left brain. It comes from their parents or somebody in their family, because we know there's an autism trait. And what happens is the left brain comes online too early, and now it stops that right brain development, or even causes it to regress or crash. And that's where they may lose words or lose eye contact or not respond to their name anymore. And then once this imbalance is established, it never self-corrects. But you can change it and correct it at any point in time with understanding that. So the first thing is about movement. And the first thing is, if your child is not hitting those milestones, if there was a problem around your birth, if you had to have a C-section, you need to ask why. Why was that the case? And was it a sign already? Then what we often see is they may have this immune dysregulation. They get reflux. They're sensitive to things like dairy. They get eczema. They have inflammation. All of these are red flags that can be seen within the first year, and you can start intervention within the first year, and that can change the whole trajectory of where it's going to go.
Wow. And I think that actually kind of lands us at the Melillo Method. Like what are some of the things that you do as you go along? I'd be also interested if you could comment on, a lot of people are like, oh, it's red dye number 6 or whatever. It's nightshades. Any thoughts on those potential assessments?
Yeah. So, there are 2 parts of the autonomic nervous system called the sympathetic fight or flight and the parasympathetic. People know it as the vagal system or the vagal nerve. It's really much more than just a nerve. It's a whole system called the parasympathetic system. And that is what regulates the gut and the immune system and our hormone systems. And that is regulated by the brain and the brainstem. So, and the basis of it is in that area of the medulla of the lower part of the brainstem where these reflexes come from. So the bottom of the brainstem is active when we're born. That's where our reflexes come from. And in the beginning, this fight or flight sympathetic nervous system is on. So a baby's on full alert. That's why they have a really fast heart rate. Their heart rates are like 140. They have very shallow, rapid breathing. They don't sleep through the night. They're not eating solid food. They have an open, leaky gut to begin with because they're getting their antibodies from their mother's breast milk. They don't have to digest anything, so they don't have digestive enzymes or acid or blood flow or any of that happening yet. And so, that's how we start. As we grow and mature, and as the brainstem matures and these reflexes go away and we go through the milestone, the gut starts to close up. The parasympathetic nervous system comes in. It calms down and slows the heart rate, and babies start to sleep. And as they start to eat solid food, we start to produce enzymes and acid, which creates the right balance of bacteria in the gut and kills any bad things like parasites or bacteria or mold, and then increases blood flow. So now we can absorb these things properly and get these nutrients in. And that should happen again within that first year. But if these reflexes don't go away, that doesn't happen. The gut stays open and leaky. They don't produce acid and enzymes the way they should. They have reduced blood flow. They have constipation. And so this is how most kids, especially with any sort of delay, but like ADHD and autism, we know that they have high sympathetic tone. The left brain the left brain activates the immune system. It activates the sympathetic. It produces more inflammatory responses. The right brain is parasympathetic and anti-inflammatory. So what we see is that we can develop, sensitivities to foods because the immune system is overreacting. We're not digesting the food properly. It gets through our gut lining, and this can produce inflammation, and that can affect our brain. But most people are told, and people in the functional medicine world that don't know really how the brain and the nervous system work with this, they're told that it all starts in the gut. And it all starts with a food, or with food sensitivities, or with, ingesting toxins, and that's not how it starts. It starts with the brainstem not developing, and then that causes this imbalance in the sympathetic and parasympathetic. So it's never just one thing. It's never just, red dye number, 5, or this, or that, or this. It's all of that can come together, and it's multifactorial. But what it does is all of these factors come together and alter the development of brain development trajectory. And that creates this imbalance in the sympathetic and parasympathetic system. And that creates all of the biomedical issues that we see. And it's not that those aren't important. Eliminating foods or reducing inflammation and targeting different things like the immune system in a very targeted way are all very important things, but they're not the root cause. You're only just kind of putting out fires and managing symptoms. They're going to develop other food sensitivities if you don't deal with the root cause. The root cause is in the brain. And I think that's a lesson that as we move forward, we realize that most autoimmune issues, food sensitivity issues, many chronic health conditions really come back to the brain and brain development. Like mental health, we know that virtually all adult mental health issues start in childhood.
Hmm. So now we've kind of walked us through how our gut is operating, or their gut is operating in this situation. So what is the Melillo method? What are you kind of doing on a regular basis? And I have this kind of back question. As you've opened up more centers, I have to imagine your feedback has been getting a lot more, right? You have practitioners doing it slightly different and maybe coming back and reporting cool changes that are, better processes. How is that kind of evolving over time?
Yeah. So, I've been doing this for a long time. I've been practicing for over 30 years, and I've been started, like I said, looking into this stuff in the early 90s. And then one of the first things I developed was, as you said, brain balance and brain balance centers. And that's great, but they were really more learning centers, and they were more geared towards more higher functioning and kids. What I really wanted to do was solve the big question, right? For me, the biggest question was, why don't kids on the autism spectrum speak? What is stopping them from speaking? Nobody's ever answered that really before. And to me, if I could figure that out, because autism was the most mysterious, but it was the same functional disconnection issue. So if I could figure out that and change that, I knew I could figure out virtually anything else, because relatively then those other things are easy. So that's where my research really focused on that, even though we work with all of it. I also am a teacher. I realized when I started realizing that I was getting results that nobody else was really getting, or I wasn't reading about, I also felt a responsibility that I needed to teach what I learned. I needed to get it out there because I knew we were facing this epidemic. So right away I started thinking from a teaching mode. And for me to teach or to reproduce, you need to have systems. And you need to have training. You need to be able to put things into like an algorithm that other people can learn and follow. So for me, it's how my brain thought right off the bat. I was like, okay, so I need to figure out how to take all of this information, boil it down, and keep a high level of individuality that could be individualized, because every patient is different, but yet follows a basic algorithm that really starts with an assessment. So I developed a battery of different assessment tools that could look at, again, movement, motor activity, muscle tone, sensory detection, processing, that could also look at, cognitive ability, academics, look at brainwave activity and development, look at the immune system, look at the digestive system, look at hormones, look at our body, our physical, and put that all together as baseline testing that then would get different results in each person. But yet it all would come down to really people that fall into more right brain delays with left brain overactivity in different networks, or left brain delays with right brain. And the bottom line is two things that really make what I do unique is the understanding of brain developmental trajectory and these retained reflexes and how brain development is delayed and maturity creates this delay, but then how that results in this imbalance. And those two things are intricately tied together with one another. You can't get rid of the reflexes without balancing the brain. You can't balance the brain without getting rid of the reflexes. And then everything else around that supports that, like getting rid of inflammation. So there was this method that I put together to really handle the most difficult things like bipolar and schizophrenia in adults and, non-speaking autism and OCD and tics and really, really high level things. And that evolved into the Melillo Method, which is what I do now. And my centers in New York, they're really, we have healthcare professionals, they're healthcare facilities. We use all really high level tools like brain stimulation tools, again, high level neuroimmune. And so it was about putting this all together and having a method that people could assess, identify, to put together an individualized treatment plan using multiple modalities at the same time, but directed towards the root cause and directed towards helping with development, removing what's blocking them, and creating a balance and communication between the networks in a very, very directed way. If somebody has an imbalance, and you do everything equally, you just stimulate the brain equally, you don't correct an imbalance. If anything, you might make it worse because the strong side responds quicker than the other side. So you need to do it in a very directed way. That's also true now in neuroimmunology. You don't just boost the immune system or depress it. You need to target it specifically to create a balance within it. So that was the basis of what we do now. And now, we're going to also, I teach that all over the world. I have online courses. I have over 10,000 practitioners that have taken my courses. And that's been the basis of my books and papers and research. And we've done all the research really to prove all of this as well.
Have you had to lean on those same studies that I was referencing, where they've actually cut the corpus callosum?
Yes, the corpus callosum. Yes.
Right. And then you end up, well, how do I, that's probably a great way to understand how I can communicate and kind of stimulate one hemisphere versus another. Right. So one graphically versus, man, I would love to have done what you've done.
Yeah. I mean, even things like different kinds of music, different frequencies of sound, different frequencies of colors and light affect the hemispheres differently. And there's, years of information. And again, I told you that by early education, but I also have a degree in clinical rehabilitation neuropsychology, and I have a PhD in developmental cognitive neuroscience from Haifa University. So I've spent my whole life studying this and doing research and understanding it at this level for this reason. And it really is cool. It's really interesting. It's really fascinating. And it's important because there is so much research on brain asymmetry. But what kills me is that if you were to Google right now, right brain, left brain, all it would come up with all these articles that say right brain, left brain is a myth. It doesn't exist. It's the whole brain. And if you look at it, I'm like, where did that come from? So I traced this back a few years ago. And if you look at it, if you go and Google it, and you'll see there's one article they keep on referencing over and over and over from the University of Utah. And I went and got that paper and read through it and looked at it, and I said, okay, I see where they're coming from. But that paper starts off by saying, of course, the two brains do different things and they regulate things differently. But their question was, is there a right brain and left brain personality type? Right? And I believe absolutely there is. I mean, we all know that. We know that there are people that are more logical and linear and detail oriented and maybe not so social, more introverted. We have other people that are really social and social butterflies and out there, maybe super creative but really not organized at all and may not do really good with details and facts. And so there are definitely, but they did this study where they looked at like 1,000 people and they did a computer simulation, and they weren't able to see that it was obvious that some people were left brain or right brain, that they favored one side of the brain over the other. And from that, they concluded that we don't think there's a right brain or left brain dominant type. Now, first of all, there's no way you would be able to see that, right? If you looked at a brain like that and said, can I tell if this person is right-handed or left-handed? You would not be able to see it. And you would conclude there is no such thing as right-handedness or left-handedness. It's a myth, right? So that was, and that's the one paper they referred to. And then there was another, I think, article by a guy at Harvard that did autopsies on dead people and said that there wasn't any right brain or left brain personality. Like you could actually see that on dead people, right? So, but yet it's ubiquitous out there. I can't tell you that I go out there and talk about this and put information and put papers out there, and I'll get, like 1,000 people or 10,000 people that look at it and comment. And overall it's good. And it's like, wow, this makes so much sense. And there's always one person that says, this has been proven as a myth. There's no such thing as the right and left brain. And it's completely wrong. As you said, if you go back to that split brain research and look at everything from there, the fact that the brain is asymmetric and that is an advantage, and that, goes back, there's probably more research on that than almost anything in neuroscience. But yet, most people today, if you ask them, they'd probably say, isn't that a myth? And it's not at all.
Wow. Wow. And that was a great example on right-handed or left-handedness, right? Like, so that doesn't prove that there isn't a right-handed or left-handed. By the way, in NICU, this is interesting. In NICU, because they're twins, they were born early, I knew that my daughter was left-handed. And it's funny because I told the nurses, so she's just like teeny tiny, right? And NICU is a neonatal intensive care, again, because they were early. And I mentioned it to a nurse, like, oh, no, you can't tell that yet. And I was like, I can tell. Like, you can just, everything she does was with her left hand already. And sure enough, she's left-handed. It's interesting how people get some perspectives. We're rapidly coming to our time. This has already been a fascinating conversation. I will get to a spot where you can kind of give your links, how to contact you. I did want to ask, if like 8 books, if somebody were to just like, hey, I'm digging what's happening in this episode, I'd like to learn more from a book, which one of your books would you suggest that they pick up?
Yeah, I think Disconnected Kids. It's my book. That's my first book after my textbook, and it's just came out in its 3rd edition this summer in August, which is a big deal, and it's been translated into 18 languages. And it's one of the best-selling books of all time in this genre by Penguin. It's the #1 publisher in the world. So, I think if you're a parent or somebody, but even for yourself, because any issues that you may have as an adult, whether they revolve around mental health issues, whether they revolve around physical, chronic issues, if you think about it, and some of these go back to childhood, and especially if you're really gifted in certain things and you struggle in other things, that's almost a sure sign that there's an imbalance in your nervous system that's been there from the beginning. And so if you read Disconnected Kids, kind of looking at yourself as a child, you'll see yourself in it. And that book is really about, how to be able to understand what the problem is, how to be able to assess yourself or your child, and then be able to put together a program to literally make a difference and change it. So it's really an instruction manual as well. So I would say Disconnected Kids. I also wrote a book on really what causes this all, called Autism, the Scientific Truth. And that's more of if a parent is nervous about having a child, or a young couple is thinking they're going to have kids and they're worried because right now 1 in 4 will be diagnosed with a disability, right? And that's increasing. And 1 in 36 or 1 in 28 boys right now are diagnosed with autism, and that's increasing That's actually a bigger number than that. So a lot of people approached me years ago and said, is there something I can do to maybe help? Now, you can't prove prevention, but what you can do is you can identify risk factors and you can modify risk factors. So in that book, I went through and I compiled all of the known risk factors that increase the risk of having a child with a disability or with autism, and that there are things that can be done pre-conception in men and women that can actually lower their risk of having a child. So that's really geared towards an adult population that may be, thinking about having kids.
Yeah, really smart. Okay, let's get into our wrap-up questions. We are a longevity, health and longevity podcast. So the first one, which you might not have gotten ever before, do you have a target age that you want to live to?
Oh, geez. Listen, I'd love to be able to live into my 90s. Reality wise, I'd say, I think, mid 80s, because, I've seen people that were really in good health and exercised a lot, and their brain was in great shape, but their body failed them. And so they're trapped with these great brains in these horrible bodies. And that's really painful. But I think, if you keep yourself in really good shape, why not 100?
100. I like it. And then how old do you think humans can live?
Oh, I think we're gonna be able to find that we can live a lot longer than we think. I would say it would be reasonable to assume 120 to 150 could be an optimal range that we could get to.
I like that. What are 2 to 3 protocols, habits, mindsets? Let's call them shortcuts because, everybody likes shortcuts to longevity and a long health span that you can share.
Number one is movement. The number one thing that drives the brain and that keeps it active is really movement. And then using it, right? There was a study on nuns called these miracle nuns in Minnesota, where not one of them, the average age was like 90, and none of these nuns none of them had ever had a history of Alzheimer's or any sort of dementia, right? Which we know is like 50% of the normal population. So they studied them to figure out why. And it turns out that these nuns they would fix their own cars. They were learning new languages at 80. They were teaching kids in school. They would do their own cooking. They did their own carpentry. They fixed their own house. They would sit there and watch Jeopardy every night. That they were just physically and mentally active, and they never got dementia. And none of them, and they were not genetically connected to one another either. So, but it really starts with movement. One of the biggest problems with technology is we become so sedentary. And the main driver, as I said, of the brain is really going to be movement. So physical movement, exercise is number one. Obviously, diet is important, but also keeping your brain mentally active is so important.
I like that. So movement, mental activity. As you were talking about kind of movement and its impact on the two hemispheres, I just remember reading somewhere, just the act of walking will relax you, right? And it's something about the motion as things are moving past you will relax you. Probably, whatever evolutionarily, if you were walking, things were not dangerous. If they were dangerous, you were not walking.
Right. Yeah, that's very true. When we look at the sympathetic and parasympathetic, it's all based on safety versus non-safety. Yeah. And that's kind of that fight or flight. So when you move, you inhibit that sympathetic nervous system. When you move your body, when you're thinking, when you're doing something, you lower that stress response in your body.
Yeah. So this one is sometimes a little more challenging, but what are 1 to 2 things people get absolutely wrong regarding longevity and a long health span?
That it's primarily based on genetics. That's wrong. Your family history matters, but it's really mostly epigenetics. We're not looking at gene mutations, and you can change your gene expression at any age. And you can alter that by how you live your lifestyle. And most of the issues and chronic issues we know are directly related to lifestyle. And I think also that, that you can't really change a lot of these mental health issues. The idea that these are lifelong conditions, ADHD, dyslexia, all of these things. And that's not true. It does not have to be that way. They're not because of genetic mutations. That's another big misconception. People think, oh, they're genetic, so there's nothing you can do about it. That's not true. They're not genetic, meaning single gene mutations, no mental health issue. It's not like Down syndrome or Fragile X or something like that. So that these things can be changed at any age. And the fact that most mental health issues literally start in childhood.
Excellent. All right, Dr. Melillo, how can people contact you?
My website is drrobertmelillo.com. And we have a lot of information. I have a lot of courses. I have professional courses that people can access right there. I'm also very active on Instagram. I have about 1 million followers, and we show a lot of information and share a lot of stuff there. I also have 2 podcasts that I do. One is called the Melillo Method podcast, Everything Brain, and the other one I do with my daughter, who's an up-and-coming singer-songwriter in Nashville, geared towards the right brain community and the creative mental health issues. And that's called the Right Brain, WRITE. And that's pretty interesting. I get to do that with my daughter down in Nashville. And then, I have the books, like I said, Disconnected Kids. I have 7 other books that I've written. I have 1 novel called Einstein's Desk that really is that I wrote with my brother, that really incorporates all this neuroscience with quantum physics and kind of explains things in a fun and interesting way. And then, I have 100 papers that can be accessed. They're all open access. They're all with some of the best journals in the world. And so anybody can go on Google Scholar or PubMed and pull them up. And then I have 2 practices right now that I am actively involved in, one here on Long Island and one in New York City, called the Melillo Center for Developing Minds. And people can, contact us right through the website. I also do a lot of lecturing around the world continually, so people can see me when I go out and do that.
And your IG is also Dr. Robert Melillo altogether, or?
Dr. Robert Melillo, yes.
Okay.
Dr. Robert
Awesome.
Melillo.
And what in the near future are you excited about?
I'm excited about, I just have this great, incredible young staff of people working with me that's so energetic because, we're making such an impact. To me, the purpose of life is to add value. And, to add the most value you can to the most people you can. So, I've been working with them, and we've really been working on perfecting our program and really developing it in the most sophisticated way, and then creating videos around it and creating software around it. And we want to really be able to export this around the world, just like we did with brain balance centers. I want to be able to do this with Melillo centers around the world. And I believe that that's going to make a huge impact. And we're also doing a lot of research and collecting data on that. I have a couple of books that are going to be coming out again, and other research papers. So, I'm very excited about that. My son's getting married this summer. I'm excited about that too.
That's awesome. All right. So you can find him, Dr. Robert Melillo, and it's Dr. The doctor is just Dr, right? Robert, and then Melillo is MELILLO.com. Same Dr. Robert Melillo for IG. Catch him with his daughter in the Right Brain podcast. That's just super cool that you're doing that. His book, Disconnected Kids, would be the first one he'd recommend. It's in its 3rd edition. I think that's pretty phenomenal. Also, Autism, the Scientific Truth. I think that covers great ways to contact you, right?
Yes, absolutely.
Excellent. Dr. Melillo, thank you so much for joining us today.
Thank you. This was great. Thank you very much. Appreciate it.
I hope you enjoyed this episode of the Live Beyond the Norms podcast. Make sure to subscribe and follow. Also, make sure not to be that guy, the guy sharing this podcast with people who are not interested in living beyond the norms. If you would like to learn more about the ESS60 molecule, the molecule responsible for the single longest longevity experimental result on mammals in history, a full 90% extension of life, visit myvitalc.com. That's myvitalc as in carbon.com.